Hey friends, welcome back to a new semester. I'm so excited to get started with you. For those of you that were with me last semester, this probably looks familiar to you. These are our Bellringers. This is similar to a warm-up that you might do at the beginning of class if you were working in person in school. And so I'm going to assign one of these for you to do each day this week. There will always be a video to go with the Bellringer, and you need to do one slide each day. Now, I will say that I did change the format of our Bellringers just a little bit for this week. So day one looks the same. This is the slide that we've been doing all along each day this week. At the end of the week, you'll submit your work all at once with written work to support it. Now, how you submit that written work is up to you. You can either take a photo of your written work and upload it, or if you want to use the pen tool in Google Slides and write your work that way, you can. But I do need to see evidence that you've watched the video and that you've solved these problems along with me. Okay, so let's go ahead and get started. This first problem asks us to identify the place value of the underlined digits. Make sure when you're answering this problem that you follow the directions carefully. There's 2 digits underlined here, and we need to identify the place value of both of them. So for this, I think it's going to be handy if we go back to our old reliable friend, our place value chart. Now this is a fairly small number. You're probably already thinking, well, this isn't too hard. Let's insert our decimal point and then go ahead and fill in the number. We have 5 ones, 2 groups of 10, 3 groups of 100, and 1 group of 1,000. So here it tells us to identify the place value of the underlined digits. So this 5 here represents 5 groups of 1, or 5 ones. And then the 3 represents 3 groups of 100, or 300. So when you submit your work to me, I will expect to see the value of those digits written out the way I showed you here. Okay, next let's look at our measurement problem. Here we're being asked to convert or change grams to milligrams. So a milligram is a smaller unit of measurement than a gram. Remember our rhyme that we use to help us convert units of measurement. Fly to horse, divide, of course. Horse to fly, multiply. So in this case, we're converting a larger unit of measurement, which is like the horse, to a smaller unit of measurement, which is like a fly, because a fly is smaller than a horse. Horse to fly, multiply. So that's a way to remember that when we convert 53 9/10 grams to milligrams, we're going to have to multiply. Now the question is, what will we have to multiply by? Well, there's 1,000 milligrams in 1 gram. So I'm going to multiply by 1,000. And Mrs. McCluskey and Ms. Hall have probably taught you to recognize this root word here. Anytime you see mille, it means 1,000. Think of like a millennium is 1,000 years. Okay? So we're going to multiply by 1,000, and that will tell us how many milligrams we have. 53 9/10 times 1,000. I'm going to put a couple zeros as placeholders, and then I simply need to move my decimal point over 1, 2, 3 spots, my bad, because I have 3 zeros. So I'm going to move my decimal point over 3 spots. That will give me a product of 53,900 milligrams. Again, so when you submit your written work, I will need to see these equations here showing me that you have solved this problem along with my video. Simply taking the answer and typing it into this blank spot is not adequate. I need to see your work here, and I need to see how you moved your decimal point over 3 spots. Okay, next we're going to convert 3 cups and figure out how many fluid ounces that is equal to. FL stands for fluid, and OZ stands for ounces. This is a unit of measurement that you're probably more familiar with, like if you make pancakes or something, you might measure out 3 cups of milk, and then we can convert those cups of milk to fluid ounces. Fluid just means it's a liquid unit of measurement. Now, luckily, there's a little clue here. We don't have to memorize how many fluid ounces are in a cup. It tells us that 1 cup is equivalent to 8 fluid ounces. Since there's 8 fluid ounces in each cup, I know I'm going to multiply again because I'm converting from a larger unit of measurement to a smaller one. So horse to fly, multiply. I'm going to take my 3 cups, multiply by 8 fluid ounces in each cup, and that's going to give me 24 fluid ounces. So that one was pretty easy. Now I can represent this visually. If I draw out my 3 cups, here's 1 cup of milk, 2 cups of milk, and 3 cups of milk. And when you look at measuring cups, have you ever noticed they show those dashes or the like notches on the side to show you, okay, here's 8 fluid ounces in this 1 cup. And here's 8 fluid ounces in this cup. And here's 8 fluid ounces in this cup. So when I fill each cup to the brim with milk, I've got 8, 16, 24 fluid ounces of milk. Again, when you submit your work, I want to see written evidence that you've watched this video. So I'll be looking to see that you have copied down your equation, you've solved it, and maybe even include the picture to go with it. Okay, next problem. This is a fraction problem. And I always like to rewrite these fractions to show the numerator on top of the denominator instead of side by side the way it is typed here, just because we're more familiar with looking at fractions like this. So here we have 3 and 5/6, and we're going to change this to an improper fraction. So let's think for a second and remember what an improper fraction is. That's a fraction where the numerator is larger than the denominator, meaning we know it is an amount that's greater than 1 whole. Anytime the top number is bigger than the bottom number, we know we have more than 1 whole. Now, the denominator is always the first place you want to look when you're working with fractions like this. Because if we have 3 wholes, that means we have 6/6 plus 6/6 plus 6/6. That gives us our 3 wholes in fraction form, plus our 5/6. So that's step 1. We don't have an improper fraction yet. What we have here is an equation that's going to help us get to our improper fraction. So now I'm going to add my numerators and then check to make sure that I do indeed have an amount that's greater than 1 whole. When you're adding fractions, the denominator stays the same, and we simply add our numerators. So 6 plus 6 plus 6 gives me 18, plus 5 more gives me 23. So my improper fraction is 23/6. Let's make sure we understand what we have here by using a visual model. Here we have 1 whole that's been divided into 6 equal pieces. So whenever we're working with fractions, it can be helpful to think about like a pizza pie or a pan of brownies or something like that. So in this case, let's pretend that we have a pan of brownies that we have divided into 6 equal pieces. So we've got 6 nice big brownies to eat. And let's imagine that somebody has made 3 pans of those brownies. So that's 1, 2, 3 holes that we have represented here with our 3. And that's 6, 6, 12, 6, 18, 6. So let's label 6, 6, 6, 6, plus 6, 6. And then we have one more pan of brownies with 1 6 missing. So that's our 5, 6. 4, 5. So if we count on from 18, 6, that would give us 19, 6, 26, 21, 6, 22, 6, and 23, 6. Okay, next we're going to subtract 2 3/34 from 23 and 567 thousandths. So let's rewrite this vertically. 23 and 567 thousandths minus 2 and 34 hundredths. I'm going to put a 0 in my thousandths place as a placeholder. And notice that I do have all of my digits lined up by place value. That's really important. Now I just need to subtract. So I can start over here with my thousandths place. 7 minus 0 is 7. 6 minus 4 is 2. 5 minus 3 is 2. Drop down your decimal point. 3 minus 2 is 1. And 2 minus 0 is 2. So our difference between these two numbers is 21 and 227 thousandths. Okay, let's go ahead and work on our volume problem. This asks us to calculate the volume of a figure with the following measurements. Length, 5 centimeters, width, 4 3/10 centimeter, and height, 2 centimeters. So I'm going to begin by calculating the area of the base. So for that, you can just kind of draw a rectangle and say we've got a length of 5 centimeters and a width of 4 3/10 centimeter. And for this, we just need to multiply these together. So I'm going to take 5 3/10 centimeter and multiply it. 4 3/10 centimeter times 5. When you multiply decimals, you don't need to worry about lining up the digits by place value. We can just go ahead and multiply this. 5 times 3 is 15. Put down your 5 and carry your 1. 5 times 4 is 20, plus 1 more is 21. Now, I have 1 digit to the right of my decimal point, so that means I need to also have 1 digit to the right of my decimal point for my answer as well. So my decimal point is going to go here. So 21 5/10 of a centimeter is the area of the base of this figure. Now we can imagine that we took 2 of these and stacked them on top of each other so that we had a height of 2 centimeters. So let's see, 21 5/10 centimeter times 2, we can just multiply that. 5 times 2 is 10. Put down the 0, carry your 1. 2 times 1 is 2, plus 1 more is 3, and 2 times 2 is 4. I have 1 digit to the right of my decimal point, so I also need to have 1 digit to the right of my decimal point in my answer. So my answer is 43 centimeters for this one. Okay, everybody, we've made it to the line plot problem. And these problems, the line plot ones, usually take the longest. So get up and do 10 jumping jacks before we tackle this one for me. Pause my video, do 10 jumping jacks, and get yourself ready, because once we're done with this, we're done for today with our Bellringer. You can do it. Okay, I'm going to begin by looking at each of these values and noticing that I have a number with a decimal, a mixed number, another mixed number, and an improper fraction. And that's 3 different formats for me to work with. And I want to slowly work towards getting all 3 of these different formats of numbers into one consistent form. So 2 5/10, I'm going to rewrite that as 2 1/2. 3 3/4, I'll leave how it is for now. 5 2/5, I'll leave that alone for now as well. And then 8/4, I'm going to remind myself that this fraction bar is also a division sign. And 8 divided by 4 equals 2 wholes. So 8/4 is equivalent to 2 wholes. That leaves me with my 3 mixed numbers to work with. And I need to put these into a form that has common denominators so that I can know where to place them on my line plot. So in order to do that, I need a common denominator that will work with halves, fourths, and fifths. Sometimes you'll see this abbreviation, LCM, and it stands for least common multiple. We need to find the smallest multiple that 2, 4, and 5 have in common, and that will be our common denominator. So the way you find the least common multiple is just skip count by each of these denominators until you come to the smallest number that shows up on all 3 lists. Now, just from experience, I can already tell you that 20 is going to be the smallest multiple that all of these numbers have in common. So I'm going to convert 2 1/2 to 2 10/20. That part's easy to do. I'm going to convert 3 3/4 to 3 and some number out of 20. So the 3 wholes, I'm just going to leave that alone. And then for my fourths, I'm going to multiply that times 5 to get 15 out of 20. So now I've got 3 15/20 instead of 3 3/4. And these 2 numbers have the same value. For 5 2/5, I'm going to convert that to 5 and some number out of 20. So I'm going to multiply both my numerator and my denominator times 4, and that will give me 5 8/20 instead of 5 2/5. And then, of course, my 2 wholes just stays the same. Okay, last but not least, I'm going to put these numbers onto my line plot. Now I have whole numbers here, so I'm going to have to make my whole number values a little bit bigger. 0, 5, 10. Okay, so I've got 2 10/20. I'm going to put that, let's see, 1, 2, 3, 4, 5. So I'm going to put that right here, 2 10/20, which is the same as 2 1/2, and then I need to put an X above it to represent this one piece of data. 3 3/4 is going to go, let's see, 1, 2, 3. Oh, geez. It's going to go right about here. Okay. 5 8/20. So 5, 6, 7, 8, 9, 10. 5 8/20. That's going to go right about here. and 2 holes. That should be easy enough right there. All right, that's it. That's our line plot, folks. You made it. I'm proud of you. Okay, so tomorrow, day 2, we have just one problem for you to solve, and I'll demonstrate how to solve that in tomorrow's video. Do one of these slides, go over the next problem in our Bellringer, and there's only one of these, so that will be a nice easy one to do. And we'll just slowly add to this assignment over the course of the week, and on Friday you'll submit the whole thing all at once. There is no need to submit this for me until Friday. Day 3 is another slide like what you guys are familiar with. And then day 4 is a division problem. So the reason I did this was to give you guys an opportunity to continue to practice multiplying and dividing decimals, which is something that's not included in all of the Bellringer slides. So these are just problems that I took from our Envisions work. Okay, but just like